I want you to just take a second and imagine that you are finally pursuing your absolute dream.
Okay, I'm picturing it.
Yeah, you are opening up this small, super vibrant souvenir shop right on the boardwalk of a busy beach town.
Oh, nice.
Right, you've got it all mapped out. You spent months sourcing the perfect inventory. You have, like, locally crafted sea glass jewelry in the display cases.
That's a good margin item, yeah.
Exactly. You've got racks of colorful flip-flops, cozy hoodies with the town's logo, and, of course, a literal mountain of sunscreen sitting right by the register.
The absolute essentials.
The essentials. You've signed the lease, the shelves look amazing, the physical space is perfect, the sun is shining, and tourists are walking by.
It sounds idyllic.
It does, but then total panic sets in.
Uh-oh. Why?
Because suddenly you realize, wait, how are you actually going to track that inventory when a family of 5 walks in, grabs 3 hoodies, 2 pairs of flip-flops, and a bottle of SPF 50?
Yeah. The logistic.
Right. And how are you going to calculate payroll for your 3 part-time employees, especially when they have different hourly rates and, state taxes?
It gets complicated really fast.
It really does. And how are you linking your backroom security cameras to your phone so you can check on the shop when you're at home?
And that panic right there is exactly where the romantic dream of running a business collides head-on with operational reality.
Yeah.
Because you realize in that split second that having physical products sitting on a physical shelf is really only half the battle.
Barely half.
Right. If you can't process the transactions, track the assets, and manage the people, you don't actually have a business. You just have a very expensive storage unit.
A very expensive storage unit. That is the core reality we're unpacking today, because the modern world might be filled with beautiful storefronts and sleek smartphones, but hardware doesn't actually drive business?
No, it doesn't.
Software does. The code running in the background is the central nervous system of modern commerce.
Absolutely.
And that brings us to the most compelling, high-stakes question this new beach shop owner, even the CEO of a Fortune 500 company has to face. How do you get that software?
That is the big question.
Do you just buy an off-the-shelf program? Or do you buy a prepackaged one and hire experts to tweak it? Or do you go all out and hire a team to build a custom system entirely from scratch?
And it's a massive strategic decision. It's not just some minor tech problem.
Right.
It's a financial and operational choice that can literally make or break a business in its first year.
Yeah, choose the wrong path. And you either bleed money on a system that's way too complex, or your whole operation just grinds to a halt on a busy Saturday.
Exactly.
Well, welcome to The Deep Dive, produced specifically for the Dr. Sampak College of Business students, and really anyone out there looking to navigate this crazy intersection of management and technology.
It's a fun one today.
It is. Today, we are doing a deep dive into Module 27, which is Software Procurement and Development in Business.
And this is such a critical shift in perspective for anyone stepping into management. But to really grasp how we procure software, we have to start with where that software actually comes from.
The raw materials.
Exactly. We have to look at the raw materials first.
Which honestly forms the perfect bridge from our last discussion. So think back to our previous deep dive on Introduction to Data Analysis with Python Part 2.
Oh, right.
The foundational realization there was that computers, at their very base level, are just empty black boxes.
Totally blank slates.
Yeah, they have incredible calculation speed, but zero inherent intelligence. They do literally nothing until human programmers provide them with excruciatingly detailed instructions.
Right. The fundamental loop is always the same, whether it's a smart toaster or a global banking system.
Input, process, output.
Exactly. They
Yep.
take input, they process it according to unforgiving, strict rules, and they spit out output.
And we spent that last deep dive looking at the really granular building blocks of that process. We talked about variables and how a computer will literally crash if you don't follow strict naming conventions.
Right. It's very picky.
Super picky. And we explored the logic of basic constructs like sequence, selection, those if statements where the machine is forced to make a binary decision.
Yes.
And loops, while and for loops that automate repetitive stuff so humans don't have to do it.
Right.
We even talked about how functions and lists can take massive CSV files and organize them into something we can actually read.
And understanding that underlying logic,
Yeah.
Knowing how the machine, quote unquote, thinks is vital.
Yeah.
But today, the aperture is widening. Now that you understand the microscopic logic of how human programmers write individual lines of code,
Yeah.
we are zooming out to the macro boardroom level.
The big picture.
The big picture. We are looking at the massive global industry that is built entirely around managing that code. We're moving from the mindset of the person typing on the keyboard to the mindset of the executive who has to decide which keyboard to buy, right?
I like that.
Yeah, who to hire to type on it, and how to roll that finished product out to thousands of employees without causing a total riot.
It's the difference between learning how to chop an onion and learning how to design and launch a massive restaurant franchise.
That's a great analogy.
Thanks. But before we get into the heavy lifting of enterprise software procurement, I have a quick favor to ask you, the listener.
Please do.
Yeah, take just a second to like, subscribe, follow, share, and comment on this deep dive. It's really the single best way to stay updated with the course and to jump into the ongoing conversation.
Hey, you read all those comments, by the way.
We do. We love seeing how you're applying these frameworks to your own careers. It makes it all real.
And the learning process absolutely relies on that back and forth. The concepts we're discussing today are highly theoretical until you start applying them, so we really want to hear your perspective.
Definitely. So let's start with the people actually writing the code.
Okay.
We know software runs the world, but as of right now, and let's leave aside the promises of AI writing its own programs for just a second, software is built by humans, specifically programmers.
Yes, human programmers. And in a business context, we really need to strip away the Hollywood mystique of what a programmer is.
The guy in the dark hoodie hacking the mainframe.
Exactly. We need to forget that.
Yeah.
Programming is simply the method of converting a real-world task or problem into a sequence of extremely precise commands that a digital device can execute.
So it starts with a problem, not with code.
Exactly. It doesn't start with code. An HR manager comes in and says, I am spending 10 hours a week manually calculating overtime pay based on 3 different state tax brackets.
Okay, yeah, that's a headache.
That is the problem statement. The programmer's actual job is to translate that messy human need into flawless machine logic.
You know, I always hear people say, like, oh, I could never be a programmer, I'm not good at math.
I hear that all the time.
But based on the profiles we see in the industry, it seems less about advanced calculus and more about being a very specific type of puzzle solver.
Yeah, mathematics is a component, obviously, but you're right. The defining trait is detail-oriented logic.
Right.
The people who thrive here have the ability to take a massive, overwhelming problem and ruthlessly break it down into tiny sequential steps. They have to anticipate every single thing that could go wrong.
I think the best way to visualize their daily reality is to imagine you are writing an incredibly precise, entirely unforgiving recipe for a highly literal-minded chef.
Well, that's perfect.
Right. If you tell a normal human chef, hey, put the butter in the pan, the human knows to take the butter out of the fridge, unwrap the foil, turn on the stove, and then put the butter in the pan.
Because they have common sense.
Exactly. A computer, though, assumes absolutely nothing.
Nothing at all.
If you don't explicitly tell it to remove the foil, it will throw a foil-wrapped stick of butter onto a freezing cold pan. Or maybe it starts a fire and then the whole system crashes. You have to specify every microscopic step.
And the stakes of that assumption are massive in business. If the computer assumes nothing, a single missed semicolon, or a forgotten step in that logical sequence, it doesn't just mean a typo on a screen.
What does it mean?
It can bring down a billion-dollar supply chain application or expose sensitive customer data to hackers.
Wow.
And because finding people who can think that meticulously is hard and who can do it collaboratively, because commercial software is built by huge teams, the financial rewards are really substantial.
Let's actually look at the numbers, because as a business major, this is where the theory hits the payroll budget, right?
Please do it.
The Bureau of Labor Statistics provides some highly revealing salary data for these roles. If you look at software developers or software engineers, the people designing the big architecture, you're looking at a median salary between $70,000 and $110,000 a year.
That's a solid living.
Right. And web developers, the folks crafting the digital user-facing experiences online, they're pulling in $60,000 to $90,000.
And the numbers climb even higher when you get into data specialization.
Like what?
Well, data analysts and data scientists. These are the people whose sole job is to make sense of massive, chaotic data sets, to find business insights.
Right, the big data people.
Exactly. Their starting salaries can easily reach $120,000.
Wow, starting.
Then you have database administrators, the gatekeepers, protecting all that stored data. They make around $100,000.
Okay, what about IT systems analysts? The bridge between the tech and the leadership.
They pull in about 90,000. Mobile app developers sit in that 70 to 110,000 range.
And security.
Oh, IT security specialists, the cyber defenders actively fighting off attacks, they're looking at around 120,000 as well.
So the overarching theme here is just massive demand.
Yes. The business need for continuous innovation and ironclad security, it literally never stops. So the valuation of these roles remains incredibly high.
But let's pause here, because I know there is a listener out there, maybe an undergraduate business major focusing on marketing or HR or supply chain, who is thinking, this is great for the computer science department, but I am never going to write a single line of Python for my job.
Fair point.
They might be thinking, to me, a database administrator and a web developer both just do computer stuff. Why do I need to care about the distinction?
You need to care because you are the one who is going to be managing them, hiring them, and most importantly, budgeting for them. Right? If your marketing department decides they need a new, highly interactive feature on the website to launch a product, you cannot just go to the finance department and ask for a generic $100,000 computer stuff budget.
They would laugh you out of the room.
Exactly.
Yeah.
You need to know that you specifically require a web developer for the interface and a database administrator to securely store the captured customer data.
Right. If you allocate a web developer's salary to hire a database admin, you're going to get someone who knows how to store data safely, but they have absolutely no idea how to make a button look good on an iPhone.
Exactly. You are burning payroll on the wrong skill set.
That makes total sense.
A data scientist costing $120,000 a year is an incredible asset if you need to predict customer buying patterns. But they are completely useless if your actual problem is that your web server keeps crashing.
So if you don't understand the distinct roles and tools, you just can't manage a project.
You will misallocate funds, you'll hire the wrong people, and your initiatives will fail before a single line of code is ever written.
That reframes it perfectly. It's not about knowing how to code. It's about knowing how to manage the people who code.
Exactly.
Okay, so once we understand who builds the tech, we need to understand exactly what they're building for our businesses. And this is where the terminology gets a little muddy.
It does.
In everyday conversation, we use the words app and program interchangeably, right? Like download this app or run this program. But in management information systems, is there an actual structural difference?
Yes, there is a very distinct technical difference, and getting this straight is crucial for professional communication.
Okay, lay on me.
A program is the broader foundational term. It refers to any piece of software that provides instructions to a computer to perform tasks.
So anything that runs on a computer.
Right. This includes the massive invisible software running on enterprise servers, and crucially, it includes the operating systems themselves.
Like Windows.
Yes, Windows on a PC, macOS on a laptop, iOS on your iPhone, those are programs.
Okay, so if the operating system is a program, what exactly makes something an app?
So an app is an abbreviation for application software. Application software is typically designed for the end user.
Okay.
It usually lives on a mobile device or a desktop, and it has a highly specific, focused purpose with a very user-friendly interface.
That's a game.
Exactly. Think of a mobile banking application, a video game, or a social media feed. The functional rule of thumb to remember is this. All apps are programs, but not all programs are apps.
Okay, let me test that logic just to make sure it tracks.
Go for it.
When my phone screen pops up with a notification that says, install the latest iOS 18 update, it is asking me to update a program, the foundational operating system that manages the battery and processor.
Correct.
But when I tap the little flashlight icon on my screen, I am launching an app.
That is the perfect distinction. The iOS program is managing the complex hardware ecosystem. The flashlight app has one single user-facing job: turn the light on and off.
And the app relies on the program to work.
Entirely. But they serve different roles.
Got it. Now, this brings us to a pretty bold assertion. We hear the phrase data-driven constantly.
Oh, it's everywhere. Every LinkedIn profile.
Right. Every company mission statement. But how does data actually mechanically drive a business engine? We know software is essential, but what is it actively doing behind the scenes?
It drives the business by fundamentally transforming responsiveness, scale, and efficiency.
What do you mean by that?
Well, software takes logistical processes that used to take human beings days or weeks, like manually counting inventory with a clipboard, cross-referencing it against paper receipts, calculating reorder thresholds.
Sounds awful.
It was. and software completes those tasks in milliseconds.
And by automating that tedious data crunching, it removes human error. Because, humans get tired and misread a 0 as an 8.
All the time. And it frees those human workers up to do the high-level, creative, strategic thinking that computers simply cannot do.
Right.
And large organizations leverage this through massive, interconnected software ecosystems. You'll hear three major acronyms constantly.
Okay, what are they?
First is SCMS, Supply Chain Management Systems. This software ensures that raw materials move efficiently from the supplier to the manufacturer to the warehouse and finally to the customer.
Okay, SCMS. What's next?
Second is ERP, Enterprise Resource Planning. Think of an ERP as the master brain of a company.
The master brain.
Yeah, it connects every single department's data, HR, finance, manufacturing, logistics, into one unified system. So the CEO can see exactly how a delay in manufacturing is impacting the finance department's quarterly projections.
Everything is connected.
Everything. And third is CRM, Customer Relationship Management. This software tracks every single interaction a business has with a client, from their first click on a website to their latest customer service phone call.
A brilliant illustrative example of this integration is Amazon's warehouse network.
Oh, that's a perfect example.
Right. When the average person thinks of an Amazon fulfillment center, they immediately picture the physical robots. Those little orange machines zipping around carrying massive shelves.
Yeah, they look like big Roombas.
Exactly. But the physical robots aren't actually the marvel. The software controlling them is. The software is a master program constantly analyzing millions of data points in real time. It knows exactly where a package is, how heavy the shelf is, the battery life of the robot, and the precise mathematical route the robot should take to avoid crashing into another robot.
Because the physical robots are entirely blind and dumb without the software.
Right. The software is the central nervous system translating the data like, customer ordered this book, into physical movement across a 1,000,000-square-foot warehouse.
And because the software handles all that dangerous, highly repetitive heavy lifting, the human workers are elevated.
Yeah, they aren't walking 10 miles a day picking items. They're stationed at ergonomic checkpoints, focusing on oversight, quality control, and troubleshooting when something goes wrong.
The data processed by the software is literally driving the physical operation of the business.
It's the ultimate manifestation of why software is the lifeblood of modern commerce. So, knowing that these systems are non-negotiable, let's look at the tools you will actually encounter out in the wild. If you're entering the business world today, there are three absolute titans you need to be familiar with. Let's call them the big three of the U.S. market.
It is almost impossible to navigate a modern corporate environment without utilizing at least one, if not all, of these platforms.
So what's the first one?
The first, and by far the most ubiquitous, is Microsoft Office 365. It remains the undisputed industry standard for daily productivity.
Like Word and Excel.
Exactly. Word for documents, Excel for complex data manipulation, PowerPoint for presentations, Access for databases, and Outlook for email.
But Microsoft didn't stay on top just by having good word processors, right?
No, what really solidified their dominance in the modern post-pandemic era is Microsoft Teams.
Yeah, Teams is everywhere.
Teams transformed Office 365 from a suite of individual desktop apps into a cloud-based, real-time collaboration ecosystem.
And because it's the backbone of so many massive global corporations, Microsoft is forced to invest billions of dollars annually into making it the industry standard for cybersecurity.
Which is huge for smaller companies. When a small business uses Office 365, they're essentially renting the cybersecurity defense budget of one of the richest companies on Earth.
That shared security umbrella is a massive selling point.
It really is. Now, the second giant in the space is QuickBooks, developed by Intuit.
Okay, QuickBooks.
If Microsoft Office is the standard for general productivity, QuickBooks is the absolute standard for financial management for small to medium-sized businesses.
What they did was revolutionary in its simplicity, honestly.
Like what?
They took this incredibly intimidating, highly regulated world of bookkeeping, managing invoicing, payroll variables, calculating federal and state taxes, and they wrapped it in a highly intuitive interface.
A small business owner doesn't need to be a CPA to use it.
Right. And crucially, they have aggressively pivoted to online, cloud-based scalability.
And that scalability is vital. When a business launches, it might only process 10 transactions a week. But if they go viral and suddenly process 10,000 transactions a week...
The software has to keep up.
Exactly. Their accounting software needs to handle that massive influx of data without crashing. QuickBooks Online scales with the company's growth.
Okay, so that's two. What's the third of the big three?
The third is Salesforce. Salesforce essentially invented the modern CRM, customer relationship management industry.
They're a behemoth.
A cloud-based behemoth that automates sales team management, tracks massive customer databases, and provides deep marketing analytics.
And what's truly fascinating about Salesforce right now is how they are integrating cutting-edge technology to stay ahead. Like, they are heavily utilizing artificial intelligence and something called the Internet of Behaviors, or IOB.
The IOB is wild.
It is, because this isn't just tracking what a customer bought. IOB involves analyzing digital behavior, like how long a user hovered their mouse over a specific image on the website.
Which is so specific.
Right. Or which emails they opened and then quickly closed, or what time of day they are most active on the app. Salesforce's AI crunches all those behavioral data points to give businesses predictive insights into how a customer will react to marketing before it's even sent.
It is predictive analytics at its absolute finest. And the practical business relevance for the listener here is very straightforward. Digital fluency translates directly to market value.
Yeah, if you walk into a job interview and you can demonstrate that you are highly proficient in Excel data modeling, QuickBooks payroll tracking, and Salesforce customer analytics, your value to that company is immediate.
They don't have to spend 6 months training you on their operational backbone because those platforms are everywhere.
Let's bring this all back down to earth and connect it to our beach souvenir shop from the opening hook.
Good idea.
If I am the owner running that shop, I'm likely utilizing all three of these platforms in concert. Well, QuickBooks is acting as my tireless digital accountant. It's tracking every single sea glass necklace sold, calculating the sales tax, and automatically processing my 3 employees' paychecks on Friday.
Perfect.
Microsoft Teams is how I'm video chatting with my hoodie supplier in a different state, sharing design files.
Yep.
And Salesforce. Salesforce is the data brain that analyzes my customer loyalty program and tells me, hey, based on historical behavioral patterns, tourists buy 40% more SPF 50 sunscreen on Tuesdays in July, so you need to order more from your supplier by Monday morning.
That seamless integration is exactly how packaged software is meant to run a business. But this leads us to a critical strategic juncture.
Which is?
What happens when the big three simply aren't enough? What if a company operates in a niche so unique or grows to a scale so massive that off-the-shelf software just doesn't cut it? Look at a company like Uber or Airbnb. You cannot run a global real-time ride-sharing dispatch system on QuickBooks and Microsoft Excel.
No, you definitely can't. And this is where the stakes get incredibly high. We arrive at the big decision. Do you procure, do you customize, or do you develop from scratch?
And choosing the wrong avenue here isn't just a minor inconvenience. It can be a multi-million-dollar catastrophe.
Let's break down the 3 distinct avenues.
Okay, the first and by far the most common is purchasing packaged software, often referred to as commercial off-the-shelf software.
So this is simply buying a subscription to QuickBooks or Office 365.
Exactly. And the pros of this approach are huge. It is intuitive, designed for the average user. Because millions of people use it daily, it has undergone extensive real-world stress testing.
Meaning fewer bugs.
Right. Vastly fewer bugs. It is much lower in cost than building your own solution.
Yeah.
If the employee gets confused, there's a mountain of training material freely available online.
YouTube tutorials for everything.
Exactly. And as we discussed with Microsoft, you benefit from robust enterprise-level security updates.
It's the safe, economical bet.
It is. But then we have the middle ground. Customizing packaged software.
Okay, so this is when an organization buys a massive, highly complex system, but then hires consultants to tweak the underlying code to fit their specific needs.
Yes. The prime examples here are giant ERP packages like SAP or Oracle.
But why would a company spend millions of dollars buying software only to spend millions more tearing it apart and customizing it?
It is usually done to bridge a specific, highly costly operational gap. For example, a standard out-of-the-box ERP might force a manufacturing company to process a material requisition in 5 separate steps.
Okay.
But if that company processes 10,000 requisitions a day, those 5 steps waste thousands of labor hours a year.
Oh, wow. Yeah.
So by customizing the ERP, they can reduce that redundancy down to a single automated step.
That makes sense.
Customization is also vital for regulatory compliance. If your business operates in a state with highly unique tax codes, a generic software package might not calculate compliance correctly.
And you definitely don't want to break the law by accident.
Exactly. So you customize the software, You're buying the stability of a massive platform, but tailoring the workflows to your unique reality.
Okay, but then there's the third option, the one that sounds the most thrilling to a visionary CEO, and honestly the most terrifying to a chief financial officer.
Developing custom software in-house,
Yeah.
building a bespoke system entirely from scratch.
Right. And the pros are obvious. It fits your exact existing IT infrastructure perfectly. You don't have to change your business processes to fit the software. The software is molded to fit your business.
And more importantly, it can provide a massive, unassailable competitive advantage.
Like Basecamp, right?
Yes, Basecamp is a great example from the text. They were a project management firm that couldn't find a tool they like, so they built their own proprietary software. It was so good, the software itself eventually became their core product.
That's the dream. But the cons of custom development are severe, right? They're often underestimated.
Very severe. First, it requires immense ongoing IT expertise. You can't just hire a team of developers, build a system for a year, and then fire them. The software requires constant permanent maintenance.
Right. It's a living thing.
Exactly. The initial and ongoing costs are astronomical compared to a monthly SaaS subscription. And perhaps most dauntingly, you shoulder 100% of the security burden.
Oh, right. Because if hackers find a vulnerability in your custom code and steal your customer's credit card data, you cannot blame Microsoft or Salesforce.
No, you can't. The liability rests entirely on your shoulders.
So if I'm the owner of that beach souvenir shop and I have a really cool idea for how I want to track my sea glass jewelry, should I take out a business loan and hire a team to build custom software just for my shop?
Absolutely not. In almost all cases, a small business or a non-tech startup should never attempt custom development.
It'll bankrupt you.
The financial costs and operational risks will crush you before you even open your doors. Custom development is generally reserved for large, well-funded enterprises, tech-focused startups whose actual product is the software, or businesses with highly unique logistical needs.
For the beach shop, buying an off-the-shelf point-of-sale system is the only rational choice.
The only rational choice.
Now, heavily intertwined with this build-or-buy decision is the question of where the software actually lives and operates. In the past, you bought a CD-ROM and installed it on a loud, overheating server in a broom closet.
The good old days.
Today, everything is cloud-based, but the cloud isn't just one thing. There are three primary cloud-based solutions that businesses utilize, and you see these acronyms everywhere: SaaS, IaaS, and PaaS.
Yep, these are the as-a-service models, and distinguishing between them is critical for IT procurement.
So what's the first one?
First is SaaS, software as a service. This is the distribution of fully functional applications over the internet. As you mentioned, there are no CD-ROMs or local installations. You simply open a web browser, log in, and use the software.
Like Salesforce or Google Workspace.
Exactly. Or QuickBooks Online. Those are classic SaaS models. Second is IaaS, infrastructure as a service.
Okay, how is that different?
This is where businesses lease raw computing resources, server space, data storage, networking hardware on the cloud, managed by a provider like Amazon Web Services or Microsoft Azure.
So instead of buying physical servers and keeping them in the broom closet.
Right, and hiring a guy to replace hard drives, you rent the infrastructure virtually. It drastically reduces upfront hardware costs and internal IT personnel needs.
And the third one?
Third is PaaS, Platform as a Service. This provides a complete pre-configured programming environment in the cloud specifically for software developers.
Oh, okay. So it's for the coders.
Yes. It gives them the operating systems, the database management systems, and the development tools they need to build, test, and deploy custom applications collaboratively without worrying about managing the underlying hardware.
I find that the easiest way to conceptualize these three is to use a real estate analogy.
Look here.
Using SaaS is like renting a fully furnished apartment. You just unlock the door, walk in, sit on the couch, and start watching TV. You don't have to worry about building the couch, wiring the electricity, or fixing the plumbing. You just pay rent and use the space.
That's perfect for SaaS.
Using IEA is like leasing an empty plot of land. The land is there, it's zoned for building, and it's connected to the city's water and power grid. But if you want a house, you have to bring the materials and build the entire house yourself from the ground up.
Which is renting raw cloud servers.
Exactly. And using PaaS is like a developer giving you the plot of land, pouring a perfect concrete foundation, hooking up all the utilities, and handing you a massive state-of-the-art toolbox full of power tools. They say, here's the perfect environment to build your house. Now get to work.
That analogy perfectly captures the varying levels of control and responsibility a business takes on with each cloud model.
So let's say a business evaluates all of this and decides they're going to take the plunge. They lease a PaaS environment, and they decide to build custom software.
Okay, big move.
They can't just put 5 brilliant programmers in a room, slide pizzas under the door, and say, start typing code.
No, that leads to total chaos.
Right. They need a blueprint, a highly structured roadmap, and that takes us into the core methodologies of development. The PDLC versus the SDLC.
These two acronyms sound incredibly similar, and they work in tandem, but they serve entirely different purposes within an organization.
Let's start with PDLC.
PDLC stands for the Product Development Lifecycle. This is the macro overarching business framework for taking a product from its initial inception, when it's nothing more than a rough idea on a whiteboard, all the way to its final release into the market.
So it's the business side.
Exactly. It's an iterative process, meaning it loops. You're expected to revisit earlier stages as you learn more. It provides the overall business direction and ensures the product actually makes financial sense.
And the framework breaks the PDLC down into 5 distinct phases, right?
Yes. Phase 1 is planning and analysis.
Yeah.
This isn't about code at all. This is defining the business goals, securing the budget, analyzing the target market.
Figuring out what stakeholders actually want.
Right. Phase 2 is conceptualization. This is where you decide if the idea is technically feasible and financially viable. You might build a rough prototype.
And crucially, this is where the business leadership makes the ultimate go or no-go decision. If it's too expensive, you kill the project here before you waste millions.
Exactly. Then phase 3 is designing. Technical experts step in to map out the broad architecture and user interface. Phase 4 is development. This is where the teams map out the specific strategic roadmap to actually build the product.
And phase 5.
Delivery and maintenance. You push the product to the users, monitor its performance, and commit to ongoing support.
So the PDLC looks at the software as a holistic business asset. But nested within that broader business strategy is the SDLC, the software development lifecycle.
Right. If the PDLC is the business strategy for the executives, the SDLC is the gritty, detailed, technical blueprint for the programmers and engineers. It focuses purely on the mechanics of creating reliable software.
And the SDLC has 6 specific steps: planning, designing, developing, testing, deploying, and maintaining. They mirror the PDLC in name, but their focus is microscopic, right?
Precisely. The SDLC planning phase isn't about market research. It's about planning server load capacities.
Okay, that makes sense. Now, the industry has spent decades arguing over the best way for a team to actually move through those 6 SDLC steps.
Oh, it's a huge debate.
And this debate has birthed different models or methodologies of software development. 3 of the most prominent are Waterfall, Agile, and Spiral.
Let's unpack these, because they represent entirely different philosophies of human collaboration.
First, the Waterfall Model. The name sounds peaceful, but in the realm of software engineering, it implies something incredibly rigid.
It is the most traditional rigid methodology. In the waterfall model, the process flows in one direction, sequentially downwards, just like a waterfall.
So you can't go back up.
No. You must completely finish step 1, document every single detail exhaustively, get formal sign-off, and only then do you flow down to step 2. Once you move down, you cannot easily swim back up the waterfall to change your mind.
Okay, I have to push back on this.
Go for it.
If the alternative, which we are about to discuss, Agile, allows teams to constantly get feedback and fix mistakes on the fly, why does Waterfall even still exist?
It's a fair question.
From an outsider's perspective, Waterfall sounds like a fantastic way to spend $15 million building a massive system over 2 years in total isolation, only to hand it to the client on launch day and watch them realize it doesn't actually solve their problem.
And honestly, throughout the 1990s, that exact catastrophic scenario happened constantly, which is why alternative methods were invented.
Right.
However, waterfall still exists and is fiercely defended in certain sectors because of predictability and massive scale.
Give me an example.
When you are building highly integrated mission-critical infrastructure, for example, the back-end transaction ledger for a global bank, or the flight control software for a commercial airliner.
Oh, okay.
You cannot have stakeholders constantly changing their minds halfway through the build. The structural dependencies are too deep. You can't just pivot and change the foundation of a skyscraper when you were building the 40th floor.
That's a good point. You want the airplane software to be perfectly planned.
Exactly. Waterfall enforces strict budget adherence, concrete technical specifications, and rigorous systematic testing against a fixed, unmoving goal. If you have too many voices constantly suggesting new features, you end up with a bloated, unstable mess.
So Waterfall locks the requirements in stone,
Yeah.
ensuring you build exactly what was agreed upon on day one.
Exactly.
Okay, that makes sense. But for almost everything else, building mobile apps, web platforms, SaaS products, and there is Agile.
Yes. The Agile methodology is currently the most popular and widely adopted SDLC model in the commercial tech sector. It represents a fundamental rejection of Waterfall's rigidity.
How does it work?
It is a highly collaborative, whole-team approach that emphasizes continuous iteration, extreme flexibility, and frequent small deliverables.
So you're not waiting 2 years for a finished product.
Right. Instead of disappearing for a year to build a complete car and hoping the client likes it, Agile says, let's build a skateboard in a week. We will show it to the client. They will tell us it needs a steering wheel. Great, next week we turn it into a scooter.
I love that.
We get more feedback. A month later, it's a bicycle. 6 months later, it's a car.
Yeah.
You are constantly adapting to user feedback and changing market conditions on the fly.
But that requires fantastic communication, right?
Right.
High trust and a willingness to scrap code that isn't working.
Absolutely. It's much faster, but it requires a very mature team.
And then there's the third framework mentioned, the spiral model. This feels like an attempt to find a middle ground between the two extremes.
The spiral model is exactly that, a hybrid. It takes the highly structured, heavily documented approach of Waterfall, and it wraps it into the iterative, looping nature of Agile.
Okay.
However, its defining characteristic is a massive, relentless focus on risk analysis. Every time you loop through the spiral planning, risk analysis, engineering, and evaluation, you're actively trying to identify what could cause the project to fail.
So it's for, like, really dangerous projects?
Yeah. Yes, it is best suited for highly complex, extraordinarily expensive, and very risky projects where, changes will be required, but where a failure could bankrupt the company. It forces management to constantly reevaluate risk before spending the next chunk of the budget.
So regardless of whether a team utilizes the rigidity of Waterfall, the speed of Agile, or the risk aversion of Spiral, they are eventually going to write the code and build a system.
Yes, they will.
But a system is entirely useless if it gets hacked on day one or if it slowly breaks down over time because nobody maintains it. Which brings us to a crucial element, SDLC security and ongoing maintenance.
This is a point that cannot be overstated.
Yeah.
Historically, security was often treated as a final checklist item.
An afterthought.
Exactly. Developers would build the software, and then right before launch, a security team would come in and try to bolt some locks onto the doors.
That sounds ineffective.
It's a disaster.
Yeah.
You cannot build a house out of glass and then try to make it secure afterward. Modern development demands a secure SDLC, or SSDLC.
Meaning embedding security considerations into every single phase from the very beginning.
Yes.
How does that actually look in practice?
Well, in the planning phase, you don't just plan the financial budget. You assess the threat landscape. Who might want to attack this specific software and why?
Right.
In the design phase, you perform rigorous threat modeling, designing the architecture to minimize vulnerabilities. In the development phase, programmers don't just write functional code, they are trained to write secure code, avoiding known exploits.
Security is woven into the very DNA of the project lifecycle.
Exactly.
And once it is built securely, it requires constant upkeep. There's a saying in tech that software is never truly finished. It is a living thing.
Very true.
The frameworks identify 4 specific types of ongoing maintenance. Let's run through them. First is corrective maintenance. This is the most reactive type.
It is exactly what it sounds like. Fixing active errors, glitches, and bugs that slip through the testing phase and are currently causing problems for users.
Okay, fixing what's broken right now. Second is preventative maintenance. This is proactive. It involves searching for and resolving latent faults.
Right, these are structural issues that aren't causing a crash today, but will inevitably cause a crash in the future.
Like what?
For example, if you see that your database is filling up faster than expected, a latent fault exists. If you do nothing, it will crash next year. Preventative maintenance is expanding the database capacity today before it becomes an active fault.
Smart. Third is perfective maintenance. This is all about enhancement and optimization.
Once a program is released to thousands of users, they will inevitably suggest improvements. Perfective maintenance is adding those highly requested new features to improve the user experience.
Interestingly, it also involves removing features that analytics show nobody's actually using, which streamlines the codebase and makes the program run faster.
Yep, trimming the fat.
And fourth is adaptive maintenance. This is modifying the software not because the software is broken, but because the outside world changed.
Like a new piece of hardware.
Right, you have to adapt it to work with a brand new piece of hardware or patch it because Apple just updated iOS and your app no longer renders correctly. Or you have to rewrite the data storage protocols because a government just passed a sweeping new privacy regulation.
The software adapts to its environment.
Let me introduce an analogy here to ground these four concepts because it's easy to get them mixed up. Think of software maintenance exactly like owning and maintaining a car.
Oh, I like car analogies.
Right. So, corrective maintenance is fixing a flat tire. The car is currently broken on the side of the road, and you have to fix it right now to keep moving.
Makes perfect sense.
Preventative maintenance is taking the car in for a routine oil change. The car is running perfectly fine today, but if you ignore this maintenance, the engine will inevitably seize up and explode down the line.
Yep.
Protective maintenance is deciding to install a premium surround sound stereo system or heated seats. The car worked fine without them, but you want to enhance the driving experience.
And adaptive maintenance.
Adaptive maintenance is swapping out your standard tires for heavy-duty snow tires because the season's changed and winter has arrived. The car is the same, but the environment it operates in demanded an adaptation.
That is a brilliant way to conceptualize the differences. And I'll add one more layer to this.
Okay.
If a development team rushes through the SDLC using Agile, skipping documentation to hit a deadline, they accrue what is known in the industry as technical debt.
Technical debt.
Think of technical debt like playing a game of Jenga.
Okay.
Every time you write a quick, messy line of code just to make something work for tomorrow's deadline, you are pulling a foundational block out of the bottom of your Jenga tower and throwing it on top.
Oh, man.
It stands up today,
Right.
but you have made the entire structure terrifyingly fragile. Eventually, when you try to do corrective or preventative maintenance later on, touching one piece of messy code causes the entire application to collapse.
That Jenga analogy really clarifies why rush software is so dangerous. So to avoid that collapse, before you ever deploy the software to the actual employees, you have to try your absolute hardest to break it on purpose.
You do. Welcome to the proving ground, the testing environment.
Testing is arguably where the most rigorous scientific engineering happens.
Because you cannot test experimental software on your company's live servers. If it crashes, it takes the whole company down with it.
Yeah.
You have to build a highly controlled, isolated sandbox.
A specific test environment.
Exactly. And the checklist for establishing this environment is exhaustive. You need the right hard... Do you have servers that accurately mimic what the end users will have?
Right.
You need the right software, all the supporting operating systems and background applications present. You need a maintenance protocol if the test environment itself crashes. Who's responsible for fixing it?
And then there is the data. The guidelines highlight a fascinating hurdle here. Creating test data is actually considered the hardest, most complex part of setting up a test environment.
It is incredibly difficult.
My initial thought is, why is that hard? If you built a new HR system, why can't you just dump all your current employees' real HR data into the test environment to see if it works?
Because doing so is a massive legal, ethical, and security violation. If you are building a new healthcare application, you absolutely cannot test it using the real medical records of actual patients. That is a blatant violation of high-pay laws. If you are building a banking app, you can't use real social security numbers.
So what do?
You have to use a process called data anonymization. You have to take a real massive data set and run it through algorithms that systematically strip out, scramble, or encrypt all personally identifiable information, or PII.
But you still need the fake data to act like real data, right?
Exactly. And that is the challenge. It is incredibly difficult to synthesize fake data that still reflects the messy, unpredictable reality of human input.
Like typos.
Yes. If your real customers frequently misspell their street addresses or enter phone numbers with weird dashes, your test data needs to include those human errors so you can see if the software handles them correctly. You have to create a fake data set of 10,000 people that perfectly mirrors the statistical distribution of reality without exposing a single real person's secrets.
Wow. I hadn't considered the sheer complexity of mimicking human error legally.
It is a monumental task.
Okay, so once you finally have that pristine test environment and your anonymized data, you run the procedures. There are 4 main categories of testing to understand.
Let's hear them.
First is functional testing. This is straightforward. Does the software actually do what the requirements say it should do? If it's a calculator app, does 2 + 2 = 4?
Good, Belinda.
Second is non-functional testing. This doesn't ask what it does, but how well or how fast it does it.
This is where you perform stress testing and load testing.
Yeah.
Sure, the app works when one person logs in. What happens when 10,000 people try to log in on Black Friday at the exact same millisecond? Does the server melt?
Right. Third is maintenance testing. This is regression testing. When we changed a line of code on Tuesday to fix a bug in the shopping cart, did we accidentally break the login screen in the process?
Happens all the time. And then we arrive at a major conceptual division in how testers approach the software. Black box versus white box testing.
Okay, explain that.
Black box testing focuses entirely on the behavior and functionality of the application from the end user's perspective. The tester does not look at the underlying Python or Java code. They treat the software like an impenetrable black box.
And white box.
White box testing, conversely, is concerned entirely with the internal structural integrity of the code itself. The tester can see inside the box and maps out every logical branch and data pathway.
Let's use a concrete scenario to illuminate the difference here. If a development team is building a brand new online shopping cart system for an e-commerce site, what exactly does black box testing look like compared to white box testing?
It's a great distinction to draw. For black box testing, the tester assumes the persona of a regular customer. They open the web browser, they click on a product, they add it to the cart, they type in a dummy credit card number, and they click the Submit Order button.
So they're just using it normally.
Exactly. They are testing the external experience. Did the confirmation screen load within 2 seconds? Did the receipt format correctly in the email? Was the user interface intuitive?
And they don't care how it works.
Right. They have absolutely no idea how the computer processed the credit card. They only care that the final output was correct. Because it relies heavily on human perception, black box testing is notoriously difficult to fully automate.
You need actual humans clicking things.
Often, yes. Now, for white box testing, the tester isn't looking at the pretty website interface. They are looking directly at the raw code in their development environment. They're verifying the internal mechanics.
It's like what happens behind the button.
Exactly. When that Submit Order button is clicked, the white box tester is checking to see if the specific integer variable inside the inventory array was mathematically subtracted by 1. They are verifying that the data passed securely from the web server to the database server without dropping packets.
Okay.
Because this is purely logical and mathematical, white box testing is easily and heavily automated. You can write a script that tests that mathematical subtraction 1,000,000 times a second to ensure it never fails.
That makes the distinction crystal clear. Black box tests the experience. White box tests the structural integrity.
Precisely.
Okay, so let's summarize the journey. We've decided to procure or build the software. We mapped out the strategy with the PDLC. We built it using an Agile SDLC to avoid technical debt. We wove security into every phase. We tested it rigorously with anonymized data using both black and white box methods.
We've done a lot of work.
We have now.
Yeah.
We face the final and often most perilous step. How do we actually unleash this massive new system on our employees without causing total operational chaos?
Oh, this is where things get really tense.
We have arrived at our final major topic, software implementation methodologies.
Rolling out a new enterprise software system to an entire organization is as much a psychological challenge as it is a technical one.
Because people hate change.
Humans fundamentally hate change, especially when it disrupts how they do their daily jobs. If management applies the wrong rollout strategy, they invite massive drops in productivity, active workplace mutinies, and they severely threaten the operational continuity of the business.
So how do they avoid that? The frameworks detail 5 distinct methodologies for managing this transition. Let's walk through these 5 strategies and evaluate the stakes.
Okay, let's hear them.
First is the Big Bang method, also known as direct cutover. This is exactly what it sounds like. You pick a date, you shut down the old legacy system completely, and you turn on the brand new system for everyone, everywhere, all at once.
Highly dramatic.
Right. Second is emergent change. This is a more organic approach, rolling out small, frequent, incremental changes over a long period of time, allowing the organization's culture to slowly adapt.
Much safer.
Third is phased release. This breaks the rollout into logical chunks. You might release the new system to the accounting department in March, the HR department in June, and the sales team in September.
Standard corporate strategy.
Fourth is pilot release. This is a containment strategy. You release the full, complete software, but only to a highly limited number of users. First, maybe just one specific branch office in Ohio.
Yeah.
You let them use it for a month to iron out the bugs and minimize the risk before deploying it globally.
Though it is worth noting that a pilot release can give a false sense of security.
Really?
Why? Because only a few people are using it, you might entirely miss massive scalability issues that will only appear when the whole company logs on at once.
Oh, right. Because the server load isn't being tested.
Exactly.
Okay, and fifth is the parallel run. This is the most conservative approach. You mandate that the company runs both the old legacy system and the brand new system simultaneously for a set period of time.
The hallmark of a great IT manager is knowing which of these 5 methodologies fits the culture, the financial risk tolerance, and the technical reality of the organization.
Well, let's debate the first one because I think it demands scrutiny. The Big Bang method.
Okay.
Why on earth would any rational, risk-averse business ever voluntarily use the Big Bang method? From everything we just discussed about how complex software is, it sounds like you are actively asking for a catastrophic disaster.
That does sound crazy.
If the new system crashes on day one, which new systems often do, and the old system is already turned off, the entire company is paralyzed.
It is undeniably the highest risk option. If it fails spectacularly. However, there are specific scenarios where it is not just an option, but an absolute necessity.
Like what?
First, consider a brand new startup, like your beach souvenir shop on opening day. You don't have an old legacy inventory system to run in parallel with. You have nothing. So you just install the new software, open the doors, and turn it on. Boom, Big Bang.
Okay, that's fair. But what about an existing company?
Second, and more relevant to enterprise business, it is used when the legacy system is completely compromised, structurally failing, or fundamentally incompatible with the new architecture.
Like if it's been hacked.
Imagine an old banking system that has been actively hacked, or a server infrastructure that is literally melting down due to age. You do not have the luxury of a gentle 6-month phased release.
Because it's too dangerous to stay on the old one?
You have to sever the cord. You shut the old dangerous system off, and you force everyone onto the new system immediately. You accept the reality that there will be bugs and employee frustration on day one, because the alternative staying on the compromised system is total failure.
So the Big Bang is either the day one startup launch, or it's pulling the emergency ripcord on a dying system. That contextualizes it perfectly. But what about the parallel run? You mentioned it's the most conservative, but there has to be a catch.
The parallel run is incredibly safe from a data integrity standpoint. If the new system crashes, you don't panic, because the old system is still running perfectly right beside it. You have an immediate real-time backup.
Sounds ideal. What's the downside?
The catch is the human toll.
The human toll.
For the duration of a parallel run, your employees essentially have to do their jobs twice.
Oh, no.
Yes, an accountant has to enter an invoice into the old system and then turn around and enter that exact same invoice into the new system to make sure they both output the same result.
That sounds miserable.
It is deeply time-consuming, it doubles the workload, and it is incredibly frustrating for users. It is a trade-off. You buy technical safety by spending employee morale and labor hours.
It all comes back to managing trade-offs. And honestly, that underlying theme is exactly what makes management information systems such a fascinating field of study.
It really is.
It is never just about the ones and zeros. It is about the complex, messy, high-stakes intersection of how human beings and business strategies interact with that code.
It's the bridge between raw technological potential and actual human achievement.
Which brings us to the conclusion of today's deep dive. I want to sincerely thank you, the listener, for sticking with us through this expansive journey. We covered massive ground today.
We really did.
Navigating the complex, high-stakes world of software procurement, the granular differences in development life cycles, and the psychological minefield of implementation. It is a massive amount of information to process.
But understanding these frameworks, knowing why we choose Agile over Waterfall, or when to buy versus build, puts you miles ahead of the competition in a management role.
You now have the vocabulary and the conceptual frameworks to sit in a boardroom and critically evaluate an IT proposal rather than just nodding along when the developers speak.
Exactly.
Before we sign off, a vital note of attribution. The overarching concepts, the structural frameworks, and the definitional distinctions we explored today were sourced from Richard Tedmon and Casey Wilhelm's excellent text, Connect Master, Management Information Systems, McGraw-Hill, 2026.
It is an incredibly robust resource for anyone looking to seriously master this intersection of business and technology.
And as we wrap up, we have one final request. If you found value in this deep dive, please take a moment to like, subscribe, follow, and share it with your classmates or colleagues. And most importantly, leave a comment.
We love the comments.
Engaging with the material is how you solidify it. Which brings us to today's discussion question. We want you to apply these theories to the real world. Think of a specific business you have worked for in the past, or even one you frequent often as a customer.
Okay, got one in mind.
Based on their unique operational needs and scale, if that business suddenly needed a brand new inventory management system, what would you advise? Based on what you learned today, would you recommend they buy packaged off-the-shelf software, or would you advise them to build a custom system from scratch?
That's a great question.
And furthermore, once that software is acquired, which of the 5 implementation methodologies would you personally use to roll it out to their employees? Would you risk a big bang? Suffer through a parallel run. Try a pilot. Let us know your specific strategy and your reasoning down in the comments.
It is always fascinating to see how listeners take these abstract frameworks and apply them to solve real logistical problems in businesses they know intimately. I'll be reading those comments closely.
It's going to be a great discussion, and you certainly won't want to miss our next deep dive. Next time, we are taking a massive leap forward into Module 28, Emerging Technologies 2025. Get ready to explore how the absolute cutting edge of artificial intelligence, machine learning, and automation are not just upgrading software, but are poised to completely rewrite the fundamental rules of business operations all over again.
It is a glimpse into the very near future, and the implications are staggering.
Until then, think back to that little beach souvenir shop on the boardwalk. The sun is shining, the flip-flops are on the racks, and now, instead of panicking, you actually know exactly how to procure the digital nervous system that will keep the doors open, track the inventory, and ensure your business thrives. Thank you for taking this deep dive with us.